This video will describe how Tidewater Planetarium calculates and displays the brightness or apparent magnitude of each of the solar system objects in the model. Here we can see Venus with its locator circle showing us where it is and its name next to it, and Mars with just its locator circle on. And we can see that Venus is displayed as very bright in the night sky, where Mars is shown as very dim in the night sky at the present time. These reflect the actual current conditions at the date and time that this simulation is showing. And those values and displays are updated continuously as the solar system objects move through their orbits. So we might expect, with Venus being so bright, that it's in a very advantageous position to be viewed from Earth. And if we look at it in the solar system view, we see, sure enough, from the Earth, Venus is really pretty close by and at not quite a 90-degree angle making a 90-degree angle between the Earth and the Sun. Mars, on the other hand, is far across space in its orbit, a pretty good distance from the Earth at the present time. So now we're going to run the simulation and see what happens to the calculated apparent magnitude. Now, if you have seen the other video, you know that apparent magnitude is brighter the smaller the number is. So at a -4, Venus is pretty bright. And we're going to run the simulation forward at a pretty good clip, and we're going to see the brightness calculation increasing as Venus gets closer to the Earth and reaching a peak at 4.34. Now it's declining again as Venus gets closer to the Earth, but less and less of its lighted surface is visible from the Earth. As it lines up almost exactly with the Earth, we see that it still has a very bright -3.24. The reason for that is that Venus has a very thick atmosphere, and the light coming from the Sun is lighting up that atmosphere from the perspective of the Earth. Now, we can't see Venus very well at this point in time because if we look back at the sky view, we see that Venus and the Sun are very close to each other. So the Sun would blot out Venus even though it's still quite bright in the sky. Now, if we run the simulation forward again, we'll see that as Venus's angle increases to the Earth and we can see more of its lighted surface, the computed magnitude and the displayed magnitude increase again, heading back up towards the 4.434 that we had before, but never quite making it because the geometry of the orbits is such that Venus gets further away from the Earth before it gets to the most advantageous angle. Now, as Venus orbits around faster than the Earth through its orbit, it gets further and further from the Earth and its magnitude drops until it reaches a minimum, I believe, of about -3.35 before it will begin climbing again as it gets directly across the orbit and we can see the full face of Venus. But once again, at that position, it will be obscured by the Sun. So there's about the minimum, and we'll see the brightness start to slowly climb back up again. So the calculations are a bit complicated to determine the actual magnitude to display, and they are constantly updated for every solar system object in the model.